So let's solve some questions under linear momentum. So I've got the first question, which is saying the diagram below are graphs of force in kilonewtons versus time in milliseconds for the motion of 5 kg block moving to the light at 4 meters per second. But A, what is the magnitude and direction of the impulse acting on the block in each case? Part B, what is the magnitude and direction of the average force acting on the block in each case? Part C, what is the magnitude and direction of the final velocity of the block in each case? So what we have to know is that whenever we're talking about impulse is given by the force times the change in time. Then momentum is given by the mass times the change in velocity. Now whenever we're talking about the change in velocity, we're talking about the final velocity minus the initial velocity. Okay, but another relationship which we have to know between impulse and momentum is that impulse is equal to the change in momentum. What does it mean? Meaning that if I have got the data for impulse, I can use that data to find momentum. At the same time, if I've got the data for momentum, I can use that data to find the what? The impulse. Okay? Now you can also say that since impulse is given by the force times the change in t, then momentum is the mass times the change in velocity. So you can now start playing around with this formula to find whatever you want to find. Okay, now in a case where you have been given the graph, like in this case, the area, if you have been given the graph and that graph is the force, if you have got the force, this is time. Okay, and we know that force is in Newton and time is in seconds. So if I do the Newton times seconds, this is going to give me what? The impulse, because impulse is the force times time, and force is in Newton, time is in second. Okay, meaning that if I'll be able to find the area under the graph, that is going to be my impulse. Okay, that is going to be my impulse. Now what we have to understand now here is that we want to find the impulse, so we have to find the area under the graph. Now the question is saying in each case, so we're going to find this graph here and there. Okay, so let's begin now. Let's start with the first one. How can I find the area under the graph? I can clearly see that I have got my shape, which is this. This is my shape which I have. Okay, so I can just say this is going to be my another shape. So I can clearly see that from this point to there it is 4, but here I can clearly see that it's 2. So I'm going to say that this is 2 and then this is also 2 on top. Then now meaning this is going to be 2. What over I have this point here, which is from this point all the way to there 5, then there is 2. So 5 minus 2, I'm going to get a 3. Now I can see that the area is going to be, the area there is going to be equal to the area under this. This is a triangle, as we can see, so it's going to be half BH plus the area of this now, of this shape here, which is the rectangle. So the area of the rectangle is L times B, meaning that the total area now will be half. The base is 3 here, So the base is 3, the height is 2, as we can see from there. The height is 2. Then I'm done there. Now L is 3, the B is 2. So I have my area to be equal to 2 and 2 can go. I'll have 3 plus 3 times 2 is 6, meaning that my area in this case is going to be this is going to be 3 plus 6 is going to be 9. Now this 9 is kilonewton per millisecond. Oh, not per, but multiplied by milliseconds. But what we have to understand is that impulse, so meaning that my impulse now is 9 kilonewton meter or milliseconds. But what we have to understand is that force is in Newton, so we have to convert our units from kilonewton to Newton. Now to convert that, what we have to know is that it's the same as saying times 1000. So it's the same as even if we just do direct, it's going to be 9 Newton seconds. Because if I do 9 times a 1000, I'm going to get a 9000. But milliseconds, meaning it's going to be 10 times 10 to the power negative 3, meaning that I'll still have 9. Okay, so that is important. We have to take note of that. So my impulse is 9 Newton seconds. Okay, for the first case. Let's go to the second one. So let me just put it here to say my impulse is 9 Newton seconds. Let's go to the second question, to the second part of, in short. Now here I can clearly see that I've got this shape, which is also a triangle, and I know that this is 2. Then the base is I have this, which is 1. I have this, which is 3. So I'll say 3 minus 3 minus 1, which is going to be 2, meaning my base is 2. Okay, so I need to find the area there. So area there, it is half BH. So area, the base is 2, height is 2, so 2 and 2 will cancel. So the first area, let me call it area 1, is 2. I leave it there. Now I need to find again the area of this. This is also a triangle, but what we have to know is that force is a vector. So from this point all the way to here is negative 4. Okay, but the base is going to be positive here. From this point, this is 3, this is 3, and then this is 7. So 7 minus 3 is going to be 4. Okay, that is what we need to know. From there, it's going to be a 4. Let's see. So I have 4, so I'm going to have area is equal to half BH. So my base there is 4, then my height is negative 4, but here there is half. So this and that here I'm going to have the area will be negative 8. Okay, now we need to add. So this is, we're going to call it area 2. So the total area is going to be the summation of area 1 plus area 2. So area will be 2 plus negative 8, which is going to give me negative 6. So this negative 6 is now Newton second, meaning this is my impulse. Impulse is a vector, so it can be negative. So that is my impulse. So the impulse here is it's a negative 6 Newton seconds. I'm done with that one. I can now go to case 2, which is going to be, I need to find the area of this guy. I'll call it area 1 there, which is going to be, I know that from this point this is 2, then from here this is 1, then this is 3. 3 minus that is going to be 2. So I have L times B. Area 1 will be, my L is 3 minus 1. We have said that this is going to be 2. So that one is going to be 2, 2. So it's going to be 2 times 2. That is area 1. So which is going to give us 4. Let's go to area 2. So area 2, I'm going to get this part here. Okay, I'm going to get this shape here. This is the shape I have. Okay, so what shape is that? I can clearly see that I have this point here from there all the way to there, which is -4. Then the base now is going to be from this point all the way to this point. So I have 5 minus 3, which is going to give me a 2. Okay, meaning that my area 2 now will be half the BH. So area 2 will be the half there. I have got the B, which is 2, times -4. So 2 and 2 can go. My area 2 is -4. So now I can add this area. I can say area 1 plus area 2. So I have my area will be 4 minus 4, which is going to be 0. So my impulse is equal to area. So impulse in this case is going to be 0 Newton seconds. So that is the impulse here. So our impulse is 0 Newton seconds. We are done with that one. We can now go to the third one. So we have got this shape here. So this shape I can divide it into 2. I can say from this point here, this is another a small triangle. Then I can treat this one to be a big triangle. Okay, so the small triangle, I'll call it area 1. Now I can see that from this point here is 2, then this point here is 1. So 2 minus 1 is going to give me 1. Okay, then the base, the height here, I can see that it ends on 4. So I'll say the H is 4. So I'll have, then this one now I can see that from this point this is 5, then this is 2. So 5 minus 2, I'm going to get a 3. So I'll say that this is 3 and then this is 1. So let's find the area of the small one. So half BH, area 1, I have the base is 1, then the height is 4. So area 1 will be equal to half. I can cancel, I can just say 2 here, 1, then 2 there is going to be 2. So area 1 will be 2. Okay, area 1 is going to be 2. Now let's go to area 2, the big one. So I have half BH. So I'll have the base is 3, the height is 4. So 2 there, 1, 2 there, 2. I can see that area 2 will be 6. Now I can add. The total area will be area 1 plus area 2. So I'll have area 1, which is 2, plus 6. Then area will be now 8 Newton per second. So since impulse in this case is equal to area, then impulse is 8 Newton seconds. So now that we are done with question part A, so I have got my impulse here, which is 8 Newton seconds. Now we are done with part Now, is the question is saying, what is the magnitude and direction? Now, the direction depends with on the sign. So now we can clearly see that the first part here, it is positive 9 Newton per second. Then the second part here is negative. So we can clearly see that since this one is negative, meaning it was going in opposite direction. So the direction is just basically the sign which we have if it is positive or negative. Okay, so that is very, very important. Now let's go to part B. Part B is saying what is the magnitude and direction of the average force acting on the block in each case. Now they want us to find the average force. But what do we know about impulse? We said that impulse is given by the force times the change in t. So this force actually is the average force. So to find the average force, I can divide both sides by change in t or just t. Then the average force will be equal to the impulse divided by time. Okay. Now let's see. We are trying to find the time. Sorry, the average force. Now we have our impulse. So now we are going to start with the first one. This is the first part. Okay. Our impulse we have already found, meaning that the impulse there is 9. Now the time is in milliseconds, so we have to convert it. Now converting from millisecond to second is just divided by 1000, or in this case, let me show you. I have this time here, this part is 2, and then this is, that is going to be what? That is 5. So 5 minus 2 is 3. Now it's the same as 3 divided by 1000 to get our time in seconds, or you just say 3 times 10 to the power negative 3. So here I can just divide by 3 times 10 to the power negative 3. 3 times 10 to the power negative 3. Meaning I've converted that one now to seconds. So force is in Newton. Now I can clearly see that this is Newton seconds, then this is seconds. So second and second will go, I'll remain with Newton. My average force will be equal to, I'll have 9 divided by 3 times 10 to the power negative 3, which is giving me 3000 Newton. So the average force for the first part is 3000 Newton. Now let's go to the second part. Now you need to be very much careful on how to find the time. Now the formula is going to be the same, nothing is going to change. So the force, the average force will be the impulse divided by time. Okay, so the impulse here is negative 6 Newton second. Then the time, now we can clearly see that what time do we have? We have the time from this point, started from here all the way to 7, meaning 7 minus 1 is going to give me 6. So I can see that it's going to be 6 times 10 to the power negative 3, meaning my average force is going to be negative 6 divided by 6 times 10 to the power negative, which is giving me negative 1000 newtons. That is going to be now my force. Okay, so I'll put it here that my force now is negative, let me just do this. So my force is negative 1000 Newton. Let's go to the third one. Using the same formula, I can see that the impulse was 0. The impulse was 0. What of the time? The time, now we can see that it started from this point, okay, all the way to this point, which is going to be what? 5 minus 1, which is going to be 4. So it's going to be 4 times 10 to the power negative 3, which is going to give us 0 newtons. So the force here is going to be 0 Newton. Oh, is here, is this question here? So the force is 0 Newton. Now let's go to the fourth one. Using the same formula, we are going to see that we have the average force to be the impulse is 8. That's what we found. We found 8 Newton seconds divided by the time starting from this point all the way to this point. So 5 minus 1 is going to be 4. So 4 times 10 to the power negative 3. So I'll have, this is now seconds. So you can see that seconds and seconds will cancel. I'll have 8 divided by 4 times 10 to the power negative 3. It's the same as just dividing 4 by 1,000, which is going to be 0.004. Okay. So I'm getting a 2,000 newtons. So that is going to be my what? My force, my average force, 2,000 Newton. Now the question was saying find the magnitude and the direction. Now the direction here, you see, you just check the sign. This is positive. Okay. So you can say that the direction, if it is negative, meaning it was going toward east. If it is positive, then it was going toward what? Or you can say north south, because here we are talking about the graph. So it's either it's going in this direction or in this direction. So you can talk about north and south. If it is negative, meaning it was going toward north or south. If it is positive, it was going toward the north. Okay, so let's now do the last part, which is part C, saying what is the magnitude and direction of the final velocity. So how do we find the final velocity? Now we should remember to say, whenever we're talking about the velocity, meaning now we're talking about the momentum, and we said that impulse is given by the change in momentum. Okay, so I can say that impulse, since I have my impulse here and I have my initial velocity. Okay, the initial velocity we have been given that it is 4.0 meters per second. So it is the mass times the change in velocity. The change in velocity is the final velocity minus the initial velocity. So we can use this formula to find the final velocity. Now I can make v final as a subject of formula, which is going to be m is going to be mv, or I can just divide both sides from here. I can divide both sides by m. Okay, I do this. I'll divide both sides by the mass, even here by the mass, meaning that I have the final velocity minus the initial velocity is equal to impulse divided by mass. Now I can shift the initial to the other side, so I have the v final will be equal to the impulse divided by the mass plus the v initial. Now I can be using this formula to find my final velocity. So what I'm going to do now, using this formula, to say v final is equal to the impulse divided by the mass plus the v initial. So let's now start plugging in the values. We have been given the mass as in 5. The mass is 5, the velocity is 4. So let's start with the first one. The first one, we have got the impulse of 9. This was the first impulse which we found. So I'm going to say the v final will be equal to the impulse is 9, the mass is 5, plus the initial velocity is 4. So I'm going to say 9 divided by 5 plus 4. Okay, so I'll be able to find 5.8. So my final velocity will be 5.8 meters per second. So that is it for part A, and it is positive, meaning it was going toward south. Oh sorry, it was going toward north because it is positive. So now we can also see that using the same formula I can now solve for this one. Now I'm going to say the final velocity is going to be the impulse we found -6 divided by the mass, which is 5, plus the initial velocity, which is 4. So -6 divided by 5 plus 4, I'm getting a positive 2, a positive 2.8 meters per second. Okay, it is also positive, we can see. Now we go to the third graph, which is this one. So the final velocity, impulse we found 6, mass is 5, plus the velocity initial, which is 4. So I have 6 divided by 5 plus 4. So this is giving me it's giving me 4 point what? It's giving me 5.2. Okay, that is the third one. No, the impulse is 0. The impulse is not 6, it's 0. We found 0 here. Okay, so it's supposed to be 0. So final velocity 0 divided by the mass is 5 plus 4. So this is going to give us 0. So the answer is 4. So the final velocity is 4 meters per second. Yes. Now let's go to the last one where the impulse was 8. So the final velocity is the impulse divided by the mass, then plus initial velocity. So impulse is 8, the mass is 5, the initial velocity is 4. So the final velocity will be 8 divided by 5 plus 4. So I'm getting a 5.6. So that is it for this one. So what we have to remember here is that if you have been given the graph, then that graph is the force versus time. You can find the impulse or the momentum using the area. So you say the area under the curve, will be equal to the impulse at the same as what? The momentum. Okay, then we can also say that impulse is equal to change in momentum. Now I can use this formula if in a case where I've been given the force and time. Maybe I want to find the velocity, I can use this formula, and I know that the change in velocity is just basically the mass, then v final minus v initial. Using this formula I can find whatever I want to find. Okay, so that is it for this question. So here is our question 2, which is saying you had been rowdy and obnoxious at your friend's party and were in the process of being thrown out by the scruff of the neck by the bouncer. The bouncer held you for 5 seconds and took you from the seated position to a final velocity of final speed of 2.75 meters per second. If your mass is 70 kg, what was your final momentum? Part 1, which is we can just say the first part. Then part 2 is saying what impulse and average force did the bouncer exert on you? Assume all motion was in a straight line. So if the motion was in the straight line, meaning It's just dialect. So we can see that we have our mass. So let's gather our data. 70 kgs. The final velocity, we have been told that it is 2.75 meters per second, but meaning that the initial velocity, the time they were taking you to throw you outside, then the initial velocity we can assume to say, not assuming, but we know that it started from rest, so it's going to be 0. Then the time, it was 5.0 seconds. What else do we know? So this is the only information we have for now. So we know that momentum is equal to the mass times the change in velocity. So momentum is the mass, the final velocity minus the initial velocity. So to find the final momentum, we're going to say you use the final velocity actually. So the mass is 70. The final velocity is 2.7 minus 0. Now the question is find the final momentum. I can go direct and say it's going to be the mass times the final velocity. But if they ask you to find the change in momentum, then I have now to say it is the mass times the final velocity minus the initial velocity. That is the change in momentum. Okay. Now, what if they ask me to find the initial momentum? The initial momentum is going to be 0 in this case because I don't have the initial velocity. Okay. So now I can use, if I want, I can use this formula, but because I know that the final velocity at this point is 0, so it's not going to affect anything. Okay. So I'm going to say that it's going to be 70 times 2.75. So 70 times 2.75, I'm going to get 192.5. My momentum will be 192.5. Now mass is in kg, velocity is in meter per second. So that is my momentum. Now the second part is saying what impulse and average force did the bouncer exert on you. Okay. So impulse, what we need to remember is that impulse is equal to the momentum. Okay, the change in momentum. So impulse, in this case, the change in momentum is going to be the same as the final momentum because the initial velocity is 0, meaning that the momentum is 192.5 kg per second. But in this case, since we're talking about impulse, I'll say 1.5 newton per second, newton seconds, meaning that is my impulse. Now another question is saying we need to find the average force. So to find the average force, impulse is given by the force times the change in t, or just t. I can divide both sides by t, both sides by t. So force will be equal to the impulse divided by t. Now I know that my force will be equal to the impulse is 192.5. The time we have been told that is 5. So I divide this by 5. 192.5 divided by 5. I'm getting 38.8. So my average force will be 38.5 newtons. So that is it for question 2. Okay, so I've got another question which is under linear momentum. So the question is saying a ball of mass 0.500 kg with a speed of 15.0 kg collides with the wall and bounces back with a speed of 10.5 meters per second. If the motion is in the straight line, calculate the initial and the final momentum and the impulse if the ball exerted an average force of 100 newton, or which is 1000 newton on the ball. How long did the collision last? Okay, so we can see from the diagram here, it is in the straight line. It was going in this direction. The initial velocity, we can clearly see that it is going in this direction. So velocity is a vector quantity, meaning that the initial velocity is going to carry a negative, okay, meaning that the final velocity is going to have a positive, because going in this direction we have been told that is positive, meaning going in opposite direction here it is going to be the negative. So let's have our data. I can clearly see that we have got the mass of the ball, which is 0.5 kgs. Okay, so this one, it was supposed to be, this is supposed to be 15. The question is saying a ball of mass with the speed, this is supposed to be meters per second and not kgs. Okay, so that is our initial speed actually. So our initial speed, now since it is going in opposite direction, we're going to say it's negative 15 meters per second. So this is supposed to be 15 meters per second. Then what else do we know? They are saying that it bounced back with the speed of, meaning that is the final velocity now. Since now it was moving toward positive x-axis or toward east, we can see that it's going to be positive 10.5 meters per second. What else do we know? We can also see that we have our force. Our force is 1,000 Newton. Now the question is, we need to find the initial and the final momentum. Okay, at the same time we need to calculate the impulse. Okay, so the question is, calculate the initial and the final momentum, okay, and impulse. So now when we're finding the impulse, meaning we're going to find the change in impulse.
Are you enjoying this video lesson? So you can actually access the entire topic you are watching or the entire practice questions of a video that you may be watching right now. So if you go to our website is transcendedinstitute.net. Okay, so there are three ways that you can access our videos. So you can use Patreon, you can use channel memberships. If you're in a country where it's allowed, you'll be able to access our full topic videos and full practice questions. So alternatively, you can access the videos using our learning portal. The link is learn.transcendedinstitute.net. So I'll show you a few videos that you can have access to after registering. So for example, if you had to open mathematics as at now, these topics are the ones that are available, which you can learn from scratch. I can just give you an idea of, so you like learn everything from scratch, meaning that even if you're learning something for the first time, these videos are there to help you with concepts as well as practice questions. So for example, these are tutorial sheet solutions from different tutorial sheets, which can help you as well get to learn faster and remember. So binomial as well, there it is. And of course, this applies to all these other topics that are available. Trigonometry as well, calculus, depending on the topic that you're interested in mathematics. So you can just head over to the site at now to check what is currently available. Even without registering, you should be able to see the content in each topic. So let's assume you're interested in physics. These are the topics available as at now. So if you open chemistry, these are the topics available as at now: electrochemistry, stoichiometry, thermochemistry, kinetics, equilibrium, solubility, equilibrium, atomic structure. So trust me, if you open these videos, you might have learned the topic in full. Let me show you stoichiometry. So stoichiometry, we have all the way up to 21 videos, including the tutorial sheet solutions, which will help you to practice both the concepts and also prepare for questions. Okay, so feel free to head over to the site and check out these videos on your own. So equally biology videos are also available, which you can also basically get to access. So these are the topics available so far. Yeah, so pretty much these are the ways you can easily access our full membership videos that you don't have access to on the channel.
Okay, or because I know that momentum, not only the change in impulse, but impulse is equal to the change in momentum. So if I have my initial momentum and the final momentum, then I'll use that information to find the what? The impulse. Now let's go ahead and find the initial momentum. So momentum is going to be, so I'll say the initial momentum is going to be the mass times the initial velocity. So initial momentum, the mass is 0.5 times the velocity initial is 15, negative 15. So I'm going to say 0.5 times negative 15, which is going to give me negative 7. So the initial momentum will be negative 7.5 kg meter per second. That is my initial momentum. Now to find the final momentum, it's going to be the mass times the final velocity. So the final velocity, the mass is 0.5, the final velocity is now positive 10, meaning that it's 10.5. So the final velocity will be 10.5 times 0.5, which is going to be 5.25. So I have my 5.25 kg meter per second. That is my final momentum. Now another question now here is we need to find the momentum. The question is calculate the initial and the final momentum and impulse. So to find the impulse, what we need to remember is that impulse is equal to change in momentum. Now change in momentum is the final momentum minus the initial momentum. Okay, so I can see that the final momentum is 5.25 minus the initial momentum is negative 7.5. So my momentum now is going to be my impulse, sorry, is going to be 5.25. Negative and negative is going to give me positive. I have this. So my impulse will be 5.25 plus 7.5, which is going to give me a 12, my impulse to be 12.75. Now the SI unit is Newton seconds. So that is my impulse. Now another question now here is saying if the ball exerted an average force of 1000 Newton on the ball, how long did the collision last? Now they want us to find the time. Now we know that impulse is given by the force times the time. I can divide both sides by the force, even here by the force, so these two can cancel. Therefore T will be the impulse divided by the force. So T will be, the impulse is 12.75, the force is 1000. So T will be equal to 12.75 divided by 1000, which is going to be 0. I'm getting 0.01275 seconds. I can round it off and say the time will be 0. Let me use different column. I can round it off and say my time will be 0.013 seconds. So that is it for this question. Now I have got a very interesting question under linear momentum. Now we need to understand this question. So the question is saying a lion of mass 120 kg leaps at a hunter with a horizontal velocity of 12 meters per second. The hunter has an automatic rifle firing bullets of mass 15 grams with a muzzle speed of 600 and 630 meters per second. Okay, and he attempts to stop the lion in mid-air. How many bullets would the hunter have to fire into the lion to stop its horizontal motion? Assume the bullet stick inside the lion. Now we need to understand this question and analyze it. For this guy to stop the lion from moving, meaning that the net momentum has to be zero. I can give you this scenario for you to understand it. Let me take you back to Newton's laws of motion. Let's assume to say you have got an object. You apply the force of maybe 50 newtons. Now, for you to stop this object from moving, meaning that the friction force here has to be also 50 newtons, meaning that the net force is going to be the 50 which is moving in this direction, or let me say the applied force. I have to put it in this way. The applied force, this is the friction force. So the summation of all the forces, in this case I can see that it's going to be the applied force minus the friction force, since the friction force is opposing the motion. So I'll say this, since it's not moving, they're going to be the same. So I'll just say the net force is 50 minus 50, which is going to be 0. Meaning that at that point, that object is not going to be moving. So this is the same principle which is there. Now the question is, a lion of mass 120 kg leaps at a hunter with a velocity of 12 meters per second. So the lion, let's have a free body diagram here. Let's assume that this is the lion here. So here is the lion. Now this lion has got the mass of 120 kgs. Then it is now moving toward the person, this person, with the initial velocity. So we're going to say the velocity, the initial velocity of the lion. Let me just say the velocity of the lion, which is 12 meters per second. Okay. Now let's think of this. So we know that we are going to have, if this is the person here, okay, this person here has got maybe this is the muzzle velocity. Now let's understand it in this way. So now the bullet, let's assume that the bullet, when he fires, the bullet will have the velocity of the bullet, let's just put it 330 meters per second. Now the mass of that bullet, we are saying it is the mass of the bullet. It is going to, so this is going to be the mass of the lion. It's going to be what? It's going to be 15 grams. Now I can convert this to kg, which is going to be 15 divided by 1000, which is going to be 0.015 kgs. Now what we need to remember is that this lion is moving in this direction. Okay, then immediately when this person shoots the gun, the bullets are going to be moving in this direction. Now this bullet is going to be bedded inside the lion. So to make the lion stop moving, meaning that the summation of all the momentum has to be equal to 0. So I'll say the summation of the momentum. What momentum do we have? We have got the momentum. This momentum is moving in this direction. So I'll say the momentum of the lion. Now, since it is moving in this direction, I'll put it positive. Now, the momentum of the gun, or let me say the bullet, is moving in opposite direction. It's going to be minus the momentum of the bullet. But what we need to remember is that the question is how many bullets would the hunter have to fire into the lion to stop its horizontal motion? Meaning that I need to put n. N will be the number of bullets. Okay, so n will be the number of bullets. So I'll say n times the momentum of what? The hand. So now we have to remember that the summation of the momentum of the net momentum has to be 0. So I'll say this is the mass of the lion times the velocity of the lion minus, so I'll say n Let me use n for different color. I'll say n, then I have got the mass of the bullet, the velocity of the bullet. I can shift this to the other side, then it's going to be n, the mass of the bullet, the velocity of the bullet is equal to the mass of the lion, the velocity of the lion. I can divide both sides by the mass of the bullet, the velocity of the bullet, the mass of the bullet, the velocity of the bullet. These guys will cancel. I'll have the number of the bullet will be, so n is the number of the bullet, mass of the lion, the velocity of the lion, divided by the mass of the bullet, the velocity of the bullet. So n will be equal to, let's see, the mass of the lion is 120, the velocity is 12, the mass of the bullet is 0.015 times the velocity is 630. So what would be the value of n? So n will be equal to, on top there I'll have 120 times 12 is giving me 1440. Down part, now what we need to remember is that this is momentum, is going to be kg meters per second. Then here I'll have 0.015 times 630, which is going to give me a 9. It's going to give me 9.45. It is also momentum, so it is kg meter per second. Now we can clear that these units will cancel. Therefore, the number of bullets which are required for it to stop the lion is supposed to be 1440 divided by 9.45. So the number of bullets that are required, they are supposed to be 152.38. Okay, so the number of bullets is going, I can round it off, so we can see that even if I round it off here, the number of the bullet is going to be 152.4 bullets. But think of this, bullets cannot be in points, so I can just say, if someone says 152 bullets, it's just okay. So 152 bullets, they are the ones which are required for it to stop the what? The lion. Now, using the formula which we said, I want us to prove this. The net momentum has to be 0. So we said the net momentum has to be the momentum of the lion minus the n times the momentum of the bullet. So this has to be the same. So we are saying that it's supposed to be 0. Let's see. So this is the mass of the lion times the velocity of the lion, okay, minus the n, then the mass of the bullet times the velocity of the bullet. If we plug in there, we have to get a 0. Now we have found that the number of bullets are supposed to be 152.4, but we have just rounded off. So let's see. This is going to be the summation, the mass. In fact, this one we found the momentum, the mass time, that one we found to be 1440 minus, now the n is 152.4, okay, and then we found this to be 9.45, okay, we found it 9.45. Let's see, 1440 minus, so what is 9.45 times 152.4? So it is also giving me 1440.2. I can say 0.2 or 0.18. Now only that we round it off. If it was the issue of not rounding off, then initially we said that this is supposed to be 152 because bullets cannot be in decimals. So I have to put 152 here for me to get the exact value. Okay, so 152 bullets are required. That's what we said. So I have to say 152 times 9.45. Okay, so if I use that one, then I can clearly see that this and this is going to give me 0.18. But if it was the issue of not rounding off, we can clearly see that if you plug in the values direct, you are going to get 0 direct, meaning that this answer is correct. So that is it for this question. So we are on number 5. So number 5 is saying on a frictionless surface, a 6 kg rock approaches from left at 3.5 meters per second. It collides elastically with a 9 kg rock which is approaching from the light at 1.7 meters per second. But A, without changing the coordinate system, find the final velocities of the rock. But B, use a coordinate system in which the 9 kg rock is not moving to find the final velocities. But C, use the coordinate system in which the 3.5 kg rock is not moving to find the final velocities. So for this question, I'm going to solve part A, then I'm going to explain on how you should go about for part B and C. And then I want you to solve part B and C, then you send the answers in the description. Okay? So let's come up with a free body diagram. We need to understand this question. So now, what is happening there is that if we have got the surface, we have got one lock, which is here, another one is here. If the collision in question 5, the one we are from solving, had been perfectly inelastic, what would have been the final velocities, the final velocity of the lock? How much kinetic energy would have been lost in the collision? Now, what we should know is that in elastic collision, after collision, these two guys will be moving together and they'll have the same velocity. So what it means there is that if this is our coordinate, we are saying that this is my m1 and this is my m2. So after collision, this is moving in this direction, it's moving in this direction. After collision, it's either these guys are going to be moving together in this direction or in this direction, we don't know. But so here is the question 7, which is saying the diagram below are the velocity versus time graph for the collision of the motion of a 4 kg block with a wall. The collision lasts for 20 milliseconds in each case. What is the magnitude and direction of the impulse acting on the block in each case? But B, what is the magnitude and direction of the average force acting on the block in each case? So let's start with part A. So here is our question 8, which is under balancing collision. So the question is a 50 kg scatter is traveling due east at 3 meters per second. A 70.0 kg scatter is moving due south at 7 meters per second. They collide and hold on to one another after the collision. Determine the magnitude and direction of their velocity after the collision. Ignore the effect of friction. Now here is our question 9. A ball of mass 0.25 kg balances of a wall as shown in the figure below or in the diagram below. The ball approaches at 15 meters per second at theta is equal to 30 degrees and leaves at 12 meters per second at phi phi is equal to 20 degrees. The collision lasts for 15 milliseconds. But A, what are the component of the impulse experienced by the ball? But B, what are the component of the average force acting on the ball? Now here, what we have to remember is that we are trying to find the x component of the impulse. Okay, so this phi is just another way of representing the angle. So if you have got two angles, they are going to use theta and phi. Okay, so that is phi, which is 20. Now let's talk about question 10, which is saying explain why a person wearing a seatbelt in a car accident is less likely to be seriously hurt than the person who is not wearing the seatbelt.
Are you enjoying this video lesson? So you can actually access the entire topic you are watching or the entire practice questions of a video that you may be watching right now. So for example, if you get to check right now, these are 4 videos which shows member only content. So for example, this trigonometric tutorial sheet is like 5 hours 48 minutes. There are other tutorial sheet solutions and other topic videos available fully here. You can see the hours that they are. So on YouTube, the ones that are available for free, just like maybe half of that, or even just a third of the total time all these tutorial sheets, you have access to them. So this is actually available in all the courses. For example, you can see chemistry as well, stoichiometry 4 hours, atomic structure. So these videos you can access them in 3 different ways that I'm going to show you. So if you go to our website is transcendedinstitute.net. Okay, so that's our website. So this is what we do. Of course, Transcended Institute, we just make story videos. So depending on your location, there are 3 ways that you can access our videos. So you can use Patreon, you can use channel memberships. If you're in a country where it's allowed, you'll be able to access our full topic videos and full practice questions. Okay, so you can also download our mobile app. The link is here. If you're on Android, I believe by the time you may be watching this video, even the iOS app may also be available. Okay, so alternatively, you can access the videos using our learning portal. The link is learn.transcendedinstitute.net. So I'll show you a few videos that you can have access to after registering. So for example, if you had to open mathematics as at now, these topics are the ones that are available, which you can learn from scratch. I can just give you an idea of, so you like learn everything from scratch, meaning that even if you're learning something for the first time, these videos are there to help you with concepts as well as practice questions. So for example, these are tutorial sheet solutions from different tutorial sheets which can help you as well get to learn faster and remember. So binomial as well, there it is. And of course this applies to all these other topics that are available, trigonometry as well, calculus, depending on the topic that you're interested in mathematics. So you can just head over to the site at now to check what is currently available. Even without registering, you should be able to see the content in each topic. So let's assume you're interested in physics. These are the topics available as at now. So you can actually just head to the site to check the topics that are available at the time you're watching the video. So for example, I can show you work. These are videos available explaining work, including the tutorial sheet based on work. Okay, let's say you're interested in circular motion. These are videos available on circular motion with tutorial sheet solutions. Linear momentum. So if you watch these videos, trust me, you should have understood the topic in full. For example, momentum, this is what you get to learn. Check the length of the videos, and I mean they are. And then I can show you now a bit of some chemistry. So if you open chemistry, these are the topics available as at now: electrochemistry, stoichiometry, thermochemistry, kinetics, equilibrium, solubility, equilibrium, atomic structure. So trust me, if you open these videos, you might have learned the topic in full. Let me show you stoichiometry. So stoichiometry, we have all the way up to 21 videos, including the tutorial sheet solutions. which will help you to practice both the concepts and also prepare for questions. Okay, so feel free to head over to the site and check out these videos on your own. So equally, biology videos are also available, which you can also basically get to access. So these are the topics available so far. Yeah, so pretty much these are the ways you can easily access our full membership videos that you don't have access to on the channel.